Welcome back, viewers. In this tutorial, I'm going to show you how to find greatest among n numbers using flowcharts. So, in previous tutorials, I have seen how to find greatest among two numbers or how to find greatest among three numbers. Now, what we will do when we have to find greatest among four, five, six numbers, seven numbers, greatest among eight numbers, greatest among 100 numbers. It is impossible. It is not possible if I have to find greatest among 1 lakh numbers. If there are 1 lakh numbers, I cannot declare variables for that. And I have already told you that our algorithm should be precise. It should not. We should not repeat anything. We should not declare variables for 1 lakh variables. In this time, at this time, when I was asked to find this greatest among two numbers only, I it was easier for me to declare variables. I declared two variables, and I found whether x was greater or y was greater. If x was greater, I was printing x. If y was greater, I was printing y. Similarly, in this case, when I was supposed to find greatest among three numbers, I was declaring three variables, and I was assigning values to these three variables and finding out whether x was greater, y was greater, or z was greater. But what if we have many if we have to find greatest among many numbers? If suppose there are 10 numbers, we have to find greatest among which we using algorithms, we should not have to declare, we cannot declare 10 variables like this, as we have declared two variables and we have declared three variables. I cannot declare 10 variables, or I cannot declare 100 variables. I cannot declare 1,000 variables even, because it is then time consuming. It is time consuming, as well as it is not precise in nature. Our algorithm should be precise in nature. Okay, it should not get any step should not get repeated. So I have to avoid declaring n number of variables. So I will make use of only two variables, x and y, to find greatest among n numbers, and I will show you how. Now what will I do? I will consider I have to find greatest among five numbers. Okay, suppose I will consider I have to find greatest among five numbers only. So what will I do? As I will suppose this n is this time 5. Okay, if I am able to find greatest among five numbers using only two variables, you can find greatest among any number. You can then find greatest among 100 also. It is if it is possible to find greatest among five using only two variables, it is also then possible to find greatest among 100 variables. Then it is possible to find greatest among 1,000 variables also. So I will do one thing. I will let me clear this first. Let me erase this all. Now I will try to draw a flowchart. I will start. Then I will read x. I will consider there are five numbers like 3, 5, 1, 2, and 4. Suppose these are five numbers. I have to find greatest among these. So 5 should be our answer at last. Okay. These are my five numbers for which I have to find which is greater. I am writing here read x. Read x. So when I am writing read x, I mean to say read the first number. Okay. This will be x. Read this x. Then when I am reading x, I am assigning serial number as 1. So I will write here n is equal to 1. I have scanned. I have read first number, and I will memorize that I have written one number. So I will write 1 here. This 1 should be our this n. I am assigning 1 to this n because I have written one number. I have scanned one number. I have read one number. Then I will read another number. Read y. Read y. When I am writing here read y, then this 5 will be read, and this will be assigned to some variable y. Okay. When I am reading another, how many numbers I have read here? I have read first and second. I have read two numbers. So I have read two numbers, and n should now be 2. I will not write like this n is equal to 2. I will not write like this. I will write like n is equal to n plus 1. Whatever there was the last value in n, whatever was the last value of n was there, I am incrementing that. I am incrementing the last value of n by 1. So from 1 it becomes 2. It was 1 here, now it becomes 2. This means I have read second number, which is 5. Now I have read two numbers and I have given serial number n as 1 and 1 plus 1 is equal to 2. Now I will check here condition whether I have reached to the last number. This is 5. This is 3, this is 4, this is 5. I will write here if n is equal to 5. If yes, then we should stop. If yes, then we should stop, because we should not then read any number again. We should. If no, then we have to work again. If no, what will I have to do? If it is no, I have to check whether this x is greater or this y is greater, because I have scanned two numbers, this x and this y. If it is no, n is not equal to 5 now. N is only 2, 1 and 2. Now what I am supposed to do here, I am supposed to check whether if x is greater than y. Yes. Okay. No. If x is greater than y, yes and no. There are two conditions, yes and no. If it is greater than y, at the time it is yes. What I have to do? But in this case, x is not greater than y. I have to assign this 5 to this x. So I have to do like this. This is 5, this is 1, this is 2, and this is 4. I have to write this 5 instead of this 3 here. I have to write this 5 here. Okay. I have to ignore this 3, previous 3. I have to cancel this. And I have to replace with this 5. So if it is no, I have to replace this x with this 5, because x is not greater than 5. It was 3 only. It was 3 only. So what I am supposed to do? I am supposed to replace it with this 5. So I will replace it with this 5. I will write x is equal to y. Whatever the value of y will be, which is greater than x, I will assign it to x. Okay. Then I will read next number. So I will go here again. I will go at this point again, where I will read again y. Suppose this was x. This was previous y. Now I am doing here. I am reading again a new number, and I am assigning that new number to y. So I will read this one. I am reading this one. Okay. And I am assigning it to y. So previously y was holding this 5. Now y will be holding this 1. Okay. Y will be holding this 1 now. Don't remember this now. We have replaced this. We have replaced this x with this value. Now there is no need of this variable. So we are leaving it as it is. Now y is replaced. Now value of y is replaced by next number. This is y. So that is why I am reading here. I am writing here read y. So I am reading y as next. What is next value? I am reading it and assigning it to y. Now again I will compare this x and now this y. So I am comparing now 5 and 1. Give increment to n by 1. So n is equal to n plus 1. What was the last value of n? It was 2 here. It was 2. So it was 2 here. Now I will write n here. N was 2. What should I do now? N is equal to n plus 1. So I will update n value of n. N is equal to n plus 1. What is the last value of n? It is 2. So 2 plus 1. N is equal to 2 plus 1, which is equal to 3. So n will be now 3. When I am reading next number, this means I have read 3 numbers. This was 1, this was 2, Now I am reading third number 3. That is why n is equal to 3 here. Okay. So n is equal to 3 now. Again, I will check whether n has reached to 5 or not. So n has not reached to 5. N is 3 only. Okay. So again, I will go to this no section. Then I am trying to find out whether x is greater or y is greater. What is x? X is 5. What is y? Y is this 1 now. Okay. So I have to compare this 5 and this 1. Okay. When I am comparing, x is greater than y. Yes. This time this 5 is greater than 1. So it will not go here. It will not go to this no section because it will only go to this no when x is less than y. But this time x is greater than y. It will go to yes section. So this time, like this, when I was replacing value of x by this value of y, then I was reading next number. In this case, also I have to read next number now without replacing. In previous case, I had replaced this 3 with this 5. Now this 5 is greater than this 1. No need to replace. And no need to replace still. I have to read this y again. So I will go to this y, read y. So next number that is equal to 2, that will be read and assigned to y. Now this y will not be here. This will be holding now this 2. Okay. This y will hold now this 2. And then n is equal to n plus 1. So n was equal to 3. Now it will be n plus 1. That means 3 plus 1, that is equal to 4. Now n will be equal to 4. If n is equal to 5, no. N is only 4 here. N is not equal to 5 now. So what will be next step here? We will be in this no part. We will not go to this yes this time. We have not been here till now. Now we are again to this no section. If x is greater than y, what is the value of y now? This is 2, and I am comparing it with x. Value of x is still the 5. X will not change like y. Y is going to each and every number coming next. Okay. Now I am comparing this x to this y. Is 5 greater than 2? Yes. So again it will not go to this no part. It will go to this yes part. Again I have to read. I don't have to change the value of x. I have not changed the value of x. So I will read y. That is 4. I have to read next number and assign it to y. So y will be holding this 4 now, and n will be incremented by 1, n will become 5. What I am checking here now, if n is equal to 5, yes, n is 5 now. So if n is 5, we don't have to go to this no, we have to go from this side. We have to go to the yes section of this flowchart. So I have to write here print x. Print the value of x. What is the value of x? This is this 5. And then I have to stop. But this flowchart is inefficient. This is inefficient. I will show you how it is inefficient. As you have seen, this was working well. Now I am going to show you what kind of inefficiency is present in this flowchart. So I will take another example here. I will take 3. Sorry, I will take 3, 3, 4, 3, 4, 1, 2, and 5. Now I am giving another 5 numbers that I am going to compare and find out whichever is greater among them. So first step, I will draw a memory map here. X, y, and n. These are the 3 variables that I have used in my flowchart. First I have to read x. So this 3 will be read here and it will be assigned to this x. Okay. And now n will be equal to 1 because I have read one number. So I will assign 1 to n. N is like counting that I have read this 3. Okay. Read y. So this 4 is to be read. and it will be assigned to this y. That means read a number and assign it to y. Read a number which is whichever is given by user and assign it to y. So n is equal to n plus 1. This n will become 2. We will increment n by 1. This n becomes 2. Now if n is equal to 5, this is not equal to 5 right now, so it will go to this no if x is greater than y. If x is greater than y, x is not greater than y, so it will go here no, x is equal to y, then this x will be replaced by the value of y, and again it will try to read next number, read y. Then I have to read a number like this one, I have to read this one and read y and assign it to y. This one will be assigned to this y. Now n is equal to n plus 1, n will become 3. If n is equal to 5, no, n is 3, it is not equal to 5. If x is greater than y, yes, x is greater than y. So this time it will not go through this no section, it will go through this yes, and this time in this case also it has to read next number. So it is going here, read y. So I have to read next number. This 2 will be read, this 2 will be read, and it will be assigned to y. So I will assign it to y here. Previous one will get replaced by this 2 now. So n is equal to n plus 1, n will become 4 now. After that, if n is equal to 5, if n is equal to 5, if n is equal to 5, is n equal to 5? No, n is equal to 4. So it will go through this no section, and if x is greater than y, is x greater than y? Yes, it will again go here and read another number and read y and read this 5 and assign it to y. This y will be replaced by 5. Previous 2 will be replaced by new number, that is 5. Now in this case, and I have read y, now I am going n is equal to n plus 1, n will become 5. Now I am writing here if n is equal to 5, but yes, n is equal to 5. This time also n is equal to 5. Now see what is the inefficiency here. N is equal to 5, yes. So I will move towards this part, yes part, and I have to print x. What is the value of x? Value of x is 4, but that is smaller than this 5. So out of this series, 3, 4, 1, 2 and 5, what is the greatest? Greatest is 5, but it is showing me greatest this 4. It is giving me one less, it is giving me second last number, second last greatest, but I have to find greatest. It should be give me a 5, but it is giving me a 4 here. This was the inefficiency. So this is due to this, because I have written here if n is equal to 5. What if I had written here if n is greater than 5? I will allow it at this point. If n is equal to 5, if n is equal to 5, I am stopping. I am going to yes and print x. No, I will move towards yes only if n is greater than 5 here. If I will write greater than 5, first of all I will try to erase this. So I have to do one thing. I have to write here if n is greater than 5, so that at this last case it will go to no part. It is going to yes and it is writing print x. It is printing this x, that is 4. Now this time again n is equal to n plus 1, n has become 5 now. I am checking it now. If n is greater than 5, no, n is equal to 5. N is equal to 5, it is not greater than 5. If it was 6, then it was greater than 5, but it is not 6, it is 5. 5 is not greater, it is equal to 5. So it will move towards no again. If x is greater than y, is x greater than y? No. So it will go here and it will replace x with y. So this x will be replaced with this y. Here it will come 5 here. Okay. Now it will again go to here, read y. This is another drawback here. It will go to read y, but we have here all the numbers we have read. Now it is going again here read y. Here it will not find any value again. This is another inefficiency lying in this flowchart, which I will cover in next tutorial.